Hey guys, good morning. This is Integrated Math 2, Note 78C today. So this will be a new idea as well. It's going to build off of yesterday's video of factoring by grouping. So today is, just to be clear on our days here, today is Thursday, March 19th, 2020. Hopefully you're on the right video for today. Okay, today the goal is going to be that I will learn to factor a quadratic expression in standard form by grouping. So today's the goal is to do all the process, unlike yesterday where we did some of it in pieces. So before we fully factor a quadratic equation by grouping, let's first practice again by finding the three GCFs given our four terms. So like yesterday, for A through D, we're going to factor by grouping from this part of the problem. So to start, I'm going to first group these four terms into two groups of two. So like that. Once I get there, my goal is going to be to GCF this 3 times. So think of it as 3 little problems. First, looking at just these two terms at this point, what do these two have in common? And notice how today they both have a 2 in common, but they also have an x in common. So I can divide out a 2x out of both of them. And so that comes out that way. And then what's left behind in my parentheses is that 2 divided by 2 is 1. Then x squared divided by x will leave me with 1x. So I get 1x here. I'll put the 1 for you. And then here, 4 divided by 2 is 2. And if I have 1x and I divide 1x out, then that 1x is out here on the outside. So there's none left here. So 4 divided by 2 leaves me with plus 2. Now, from yesterday we said that once in this process, whatever this is has to be the same over here on this side. So at this point, if I want to, I can simply just write this automatically as 1x squared plus 2. In other words, I can copy this over here automatically. It has to be the same for this to work. So the question becomes, what should I divide these two by to get this as a result? So the GCF here that I can divide by is going to be 3. If I divide each of these by 3, so this 3 comes out here on the outside of the parentheses, then I'm left with 3 divided by 3 is 1x, good, and 6 divided by 3 here is 2, so that works. So notice how at this point in my problem, this factor and this factor are the same. That's what I need to happen. Now to finish, I need to now GCF one more time. So now looking at this big old term and this big old term, they both have an x plus 2 in common, which is what I have here in green. So I'm going to divide that out of both of them. So this comes out of both. And then what's left behind is 2x and then a plus 3. That becomes your other factor. So in this example, this is a complete response. This is the factored form of my quadratic. These are called factors. This is a factor, this is a factor. And this is the goal for today, that we can factor a quadratic expression by grouping. Look, at this point, go ahead and pause the video. Please try examples B, C, and D. And when you hit play again, they'll be fully worked out, and I'll go over them briefly. And then we'll go to today's main goal, which is going to be factoring from the very beginning all the way to factored form. So please pause the video and try B, C, and D. Look, I'm being serious. Alright guys, so hopefully you're back. So let's look at each of these briefly. Example B, in this group first, they have 4x in common. I take that out. So 4 divided by 4 is 1x, and then here I get 7. Notice how at this point that these have to be the same every time. So as I go through each example, x minus 2, x minus 2, x plus 3, x plus 3. So in this process, please be aware that as you factor by grouping and you GCF the little pairs initially, you have to have the same thing come out here in this process. A couple of notes here I want to make. Notice how in example C, in this example down here, so look at the red dot, here I have x minus 2 in a group. Notice how that's already what I have here in my parentheses. So sometimes your GCF will just be dividing by 1. That's all that they share in common. So here dividing by 1 gives me a plus 1 here on the outside. And then I still have my x minus 2 here in the parentheses. So be careful that sometimes you're like, there's no GCF. 1 is always a GCF if you need to use that. On example D, as you're scanning these different works here, notice again that when you have a negative sign, that's part of your group. So there is a plus here that I'm not writing out of being a little bit lazy on my part. So there's a plus sign here between these two groups that I'm not writing down. So here I have divided by a negative 5 because I want this to become an x plus 3 to match to this one. So notice how by dividing by a negative, I get here a positive at 1x, which is what I need. And here also, dividing by two negatives here, I get a positive 3, which is what I need to match this. So you're in control of what you're dividing by as far as pluses and minuses, as long as these come out the same. Lastly, guys, these are all called factored form. We factored here, so these are the answers. So this is factored form, this is factored form, and this is factored form. And we saw it in class already when we found the zeros. So that we're going to head there after these notes. But these are all called factors. This is a factor. This is a factor. X minus 2 is a factor. 3x plus 1 is a factor. X plus 3 is a factor. 2x minus 5 is a factor. Okay, and so with that, here's now the goal for today. Here's the new idea. The goal today is, can we factor a quadratic expression by grouping? And it's going to take 4 steps. The first step we will not do today to keep it kind of a little bit easier, but you should always look to factor out a GCF in the very beginning if possible. For today's examples, that's not going to happen. We'll deal with that later. Step number 2, identify A, B, and C values and complete the X factor puzzle. Step 3, rewrite the original problem by splitting the B value using the X factor puzzle. And then finally, like we've done now for 2 days now, you're going to factor by grouping by GCFing 3 times, which you've seen above and you saw yesterday. So let's start with example E. Here we go. So step 1 is, or step 2 is, in this case, let's identify A, B, and C. And you're already good at that for quadratic expressions. In this case, A is 1, B is negative 1, and C is negative 20. You've done this for about a month, so you're good at this already. So then it says, let's make the X factor puzzle. So here's our X factor puzzle. So we draw an X. Now, the number on the top here will always be A times C. So whatever your A and your C values are, you're going to multiply them and put that number right in this place. So in this case, A is 1, C is negative 20. So 1 times negative 20 is negative 20. So that's what I get here. That's how I find what number I place in this X factor. Down at the bottom of the X, that's always going to be your B number, just whatever B is. Remember, just the number. In this case, B is negative 1. Please don't put the X, just the number negative 1. So that's going to go right in here, negative 1. At this point, it's going to be your job, like from yesterday's notes, to complete the X factor puzzle. So as a reminder, here's how this works. We're going to take this top value, which was A times C, and we're going to list all the factor pairs. So all the factor pairs. So 20 is 1 times 20. It's 2 times 10. 3 doesn't work because you can't divide it by 3 evenly. And it's 4 times 5. And that's it. So the question is, of these 3 factor pairs, which of them can combine to make negative 1? And hopefully you can see that 4 and 5 can make 1 in some way. So I'm going to choose these 2. So I'm going to put these 2 into my puzzle. Then your last job is going to be to look at the signs. So right now as it stands, if I were to combine 4 and 5, 4 plus 5 is 9. That's not what I have here. So who should I make negative to make this into a negative 1? The 4 or the 5? And hopefully you're okay with me saying that by making the 5 negative, this puzzle will work. Let's check. So let's check first. If I multiply 4 times negative 5, do I get negative 20 like I had up here? And I do, so that's good. Check. Next, if I combine 4 minus 5, is that negative 1 like I have here? I get that also, so good. So in this case, I've satisfied my x puzzle. So next, and this is the new part, the whole point of making this x factor puzzle is that it gives us a way to split our b value. So this number here and this number here, the numbers that we just found in this whole process, all that they're going to give to us is going to give us a way to split our original b value, negative 1, into now 4 minus 5. So I'll show you here on the next little bit. So here's the original problem. Oops, let me switch my function here. So x squared, this is the original question, minus 1x minus 20. The whole point of this whole process here, the x factor, is to find a way to split this negative 1x here into now 2 terms, which we just found to be 4x minus 5x. I'm going to add the x back in now. So using the numbers 4 and minus 5, you'll see here. 4, and then I'm going to add the x and minus 5. Can you guys see how basically 4x minus 5x is the exact same thing as my original minus 1x? That's all this is doing for me. It allows me to split this, because if I do that, then the x squared still comes down the same. So I got x squared. And then the minus 20 is still there. Notice what I just created. I just created a quadratic with 4 terms. That, like we did yesterday and above today, I can now group these. I can group these, and I can factor by finding GCF 3 times. So that's how this works in its entirety. So now, let's finish this off here real quick. I'm a little messy on this side. Let me make some space here. Okay. So now let's factor by grouping. So let's group the first 2. So the first 2 like this, and the second 2. This should be familiar to you guys. GCF 3 times. So here we go. This has an x in common. So that comes out. And end up with x plus 4. This has a minus 5 in common. And I get what I need here, the exact same x plus 4. Okay, notice how these are the same, because they need to be in this process. And then lastly, to finish off, notice how I'm going to GCF one more time. So looking at these 2 terms, they both have the x plus 4. So I'm going to take that from both of them. And if I take that from both of them, so I'll scratch it out for you, I'm left with x minus 5. That's my other factor. And this is the answer. So our goal today is to do all these things to one question. Please don't look at it in its entirety. Look at it as steps. We did each step individually before. Now let's put it all together into one longer problem. So again, step 1 for us, identify A, B, and C, and make the x factor puzzle. We did that yesterday a little bit by itself. The only point of this whole process here is to find these 2 numbers. These 2 numbers will allow us to then split the original b value into 2 different terms, to 2 equivalent terms. Once I have that, I'm going to have my 4 terms that I can then group, and I can GCF 1 time, 2 times, 3 times to get my factored form answer. This is the goal today. Okay, I'm going to show you, actually pause the video, please try example F because it's similar, and then hit play and look at that response. And then I'm going to show you example G at that point. Watch that one please, and you can pause that and then you can try the other 3 on your own. And that's today's lesson. So please pause and try F now, and then come back. Alright guys, so welcome back. Hopefully you tried F and used E as an example. So really quickly, example F, A is 1, B is -5, C is -24. In doing the X factor, I made my lists. Notice how I verified at the end to make sure everything works. So when I multiply 3 and -8, I do end up getting -24, which is what I needed there. And when I combine them, 3 minus 8 is -5. So this satisfies the puzzle. I can make both these numbers work with these two that I found. At that point, remember the only point for this process is that these two numbers allow me to split my original b value into two terms that are worth the same thing. So 3x minus 8x is still just minus 5x. But now I have my four terms that I can group and GCF 1, 2, and then 3 times. Okay, notice how this is the exact same. So I can pull it as my answer here. And then I get to my factored form. Some questions in the past that I've had from students: does it matter if you put x plus 3 first or second? It doesn't matter the order that you write your factors. So this is the right answer. You can equally just write x plus, oops, let me switch that over. You can equally just write x plus 3 and x minus 8. They're the exact same thing. So don't worry about which factor comes first. It does not matter. Also, when you split your b term, same is true here. It doesn't matter what order you put these in. It'll work the same way at the end with the answer. Okay, one more for me. So this requires a little more explanation, so it's a little bit of a longer video, but one more for me, and then you can just kind of try the rest on your own and go from there. So in this case, this is another example of a quadratic expression. So first step is what's A. So here A is 4, B is 5, C is -6. So let's make our X factor puzzle. So remember that it's always going to be A times C on the top part of this puzzle, and then the B number on the bottom. So in this case, this is where it's a little bit different. In this case, A times C is 4 times -6. So 4 times -6 is -24. So -24. Your B number is just going to be 5, which is going to be 5. At this point, to complete the X factor, you make a list of all the factors of -24 in this case. So I get 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. And of these four factor pairs, the one that can combine to make 5 looks like 3 and 8. So I'm going to choose 3 and 8 to put into my X factor. Now in this case, notice how this is a plus 5. So 3 plus 8 is 11. That's not going to work. But if I make the 3 a -3, like that, then 8 times -3 is -24, so that works. At the exact same time, 8 minus 3 is 5. So this is a completed puzzle. So I now have my two values here that I'm going to use to split my b term. So here's my original question, 4x squared plus 5x minus 6. But I'm going to split my original b term to now be minus 3x plus 8x. Remember, that's the whole point of the X factors, just to find these two numbers that can split my b term to be two terms. I'm going to now bring down the original 4x squared here. That won't change, or the minus 6. So I'm only splitting the middle term. The first term comes down the same. The third term comes down the same. And look, now we're here to our familiar four-term quadratic that I can group and GCF 3 times. So I'll go here again, grouping the first two and the second two. Looking at the first two terms, is my first little group. They have an x in common, so I'll take that out, leaving me 4x minus 3. And then, remember, I can, at this point, automatically just drop down the 4x minus 3. It has to be the same. So what should I divide these two by to end up with 4x minus 3? In other words, what do they have in common here? They both share a 2. So I'll divide these by 2. So I'll bring that down there. And 8 divided by 2 is 4, minus 6 divided by 2 is negative 3 or minus 3. And notice how, again, I have what I need in the sense that this factor is the same as that factor. So that has to happen. To finish, and then we're done with this for lesson for today, is I can take the common 4x minus 3 that they both have here in green. So I'll take that out, and then I'm left with x plus 2. So this is called factored form. I factored this quadratic. So this quadratic expression is the same as this quadratic expression in factored form. Factored form, standard form. And as a quick check, I can always multiply what's negative 3 times 2. If I just check that, is that going to be negative 6? And it is, so I have a quick check to see if it looks reasonable. So I'm in the reasonable range just doing that. Okay, with that guys, it's been 21 minutes. Please pause the video, try the next 3 examples on your own as classwork, and then just once you try them, come back and check, and the answers will be posted for you. Alright guys, again, from my family to yours, please stay safe, and I hope to see you guys soon. Alright guys, so with that, again, here's now H, I, and J. I know it's a lot to look at. Please pause it here, look at the work, see if you understand how it flows from beginning to end. This will be our goal for today and tomorrow, and honestly into probably the week after, but this is going to take some time. So the idea is that can we factor a quadratic expression in standard form, go all the way to its equivalent factored form. So yeah, please pause it. We miss you guys as a math department. I know I've talked to my colleagues. We're all worried about you guys. Hopefully you're doing fine. And we can't wait to see you guys again back on campus. Alright guys, till next video. Take care.